Yeah.
So, right. So let me re-summarize. I think what you said is you've modified the auto trait constituent types to always return the tuple.
Yes.
And then in the diagnostic reporting code,
Mm-hmm.
if you see a tuple whose parent is a closure
Our
for a
generator.
generator, you ignore it.
Yes.
That sounds fine. Yeah, that's kind of what I thought would make sense.
Yeah.
Go on.
Oh, I think a more cleaner way would have been that in the diagnostic builder we could pop off things, but I think this seems logically still the same. Like it just a little bit of looks like a bit more duplicated code than I would like, but
It
it
seems a bit
represents
complicated, but yeah, it's a little bit
it,
of a shame to distribute this information, like the fact that it's a tuple is now repeated in different parts of the code, kind of.
I was saying that we could probably do something like we could probably just alias ty tuple to be
Yeah.
that the upper type inference thing, so that in case ever it changes or something, at least it's easier to work on. But I don't know if like I can go do it. That's not a problem. But other than that,
So yeah, and the original plan that I had with the last time we tried this was to modify the
obligation code.
obligation cause so that we would know to skip it based on that. And there would be other ways you could imagine, like we could introduce a new variant of tuple that's like internal tuple.
Yeah,
But it just seems like a lot of code for
yeah,
like what is ultimately 3 lines of code in this
yeah.
thing. It's not worth it. Yeah,
We
I
tried it.
agree with it. It's
I
okay.
tried a couple other things. Well, one or two other things of trying the obligation code, like putting in different places, but that didn't seem to work either. So
Yeah, sometimes a judicious hack is the
yeah.
right way out, is my opinion.
Okay. Yeah.
Uh,
So hopefully we'll clean this up over the weekend. I think there's only a couple small things. Get it sort of just like looked at within ourselves to catch any obvious errors, and then hopefully by Monday we'll have this for review.
Great. Can you,
And
if you want me to review it, well, actually this weekend I plan to clear all of my GitHub notifications and actually try to keep up with them again.
okay.
Declare bankruptcy. But if you, nonetheless, please do like mercilessly ping me with things that need review because that will.
No, yeah. This was like on Monday. When I said internally, I meant like within the 5-7 of us. Just take a look so that like we're not wasting your time for obvious errors. If it gets. So there's that. If you want, I can. So we ended up doing most of the code for minimum analysis using a bridge. But if you want, I can. It's not too much from a like. I can show you what the final structure now looks like.
Can we
Uh,
by the way, I think it would be really useful to me. These meetings are great. I'm wondering, is there somewhere we should be taking notes, or like, do you have a?
uh,
I guess I'll just post some random things into Zulip for now. But okay, so.
yeah. Okay. I think that would be. Yeah. We probably should do that. I do have some like most of these are being based on comments that we have already had. I'll share another doc with you that I'm working on, but haven't got to
Yeah, I was thinking like
completing.
we have the project board right in the
Yeah,
repo,
yeah.
and I'm wondering if we can use that to like or something like that. It would be great if there was something we can go to later. I can go to later when I'm like in the Lang team meeting or something and say,
Uh,
here's where we are.
no, everything up there is basically up to date. From it doesn't have as precise information of what we're doing like internally, but what's being worked on right now is up to date. So I'm making sure that's there.
Okay,
Uh,
so here's what we got now, right? Did I share the right window?
I it hasn't shown up for me yet.
That's okay. Maybe I shared the wrong thing then. Why did it do that? No, it should be right. Yeah, do you see it now?
I do see it now. So yeah.
So we just talked about this.
We talked about issue
Now
4. So
talking
we're
about
talking about issue 9, which kind of builds up on issue 7. So they kind of will go in together because unless, yeah.
in the summary,
So
this is like just so update. We are always using tuples in auto rate selection, and we have a hack to fix diagnostics. And did you fix the async await thing?
Yeah, that also got fixed. It's a very similar thing. If the first thing we see is a tuple, then we ignore it. And just ignoring that fixes things. So the only UI changes that are there is something that should have fixed in print. So there's, it would print the generator witness if things are resolved. But now if we have an inference variable for the upper types, it won't print the generator. So again, if you go on the same PR that's linked, okay, yeah, it's the PR 23 that you see up here, Roxello. So if you go to the bottom, that right above that one.
Got it.
That, yeah. So if you look in the diff for this.
Yep.
Or like file change. The only outputs that are different are like we do not have unresolved witnesses being printed anymore, which
seems like
I should have fixed. Like it's nothing that's going to cause problems, but I felt like this PR could have been cleaner if I had caught this in the pretty print stuff.
Yeah, like this, you mean?
Yes, it's the yeah.
I mean, that seems like an improvement. So
it is. It's just like it could have been, the PR could have been cleaner.
Got it. Okay, seems very good. All right, so let's talk about minimal places and here place, I guess.
Okay, so it might be easier. I can either just send a teammate link or I can just share my screen. Either works with me.
Why don't you just share your screen?
Actually, I have the code, so I might just send you on GitHub. I'll share screen. Easier. Sorry.
No problem. I'll stop. I may have to give you permission.
Yeah, you have to. Yeah, I think I need permission from you. Yeah. Okay, I think that should be good. And I want to share that. Can you see my terminal?
Yep.
Okay. So.
Oh, what is Z?
Z, it's basically like keeps a most recently used. It's CD, but it's smart about it. So it keeps a track of substring search, and then does most recently used. And where does? I think this is mod. That's where that is. And oh, I am on the wrong branch. Yeah, so give me a second. So we discussed last time that our kind of the structure we sort of going with and storing information is going to be capture information. So this is going to have an expression ID, which is basically where a place is being used so that we can use it for diagnostics. Reason it's optional is because when we do the initialization for old analysis, we would not have the use expression. So we initialize it to an option. Worst case scenario, our fallback would be the span that's recorded in upwards mentioned. Now, then we have the structure, which would be
again. So we have a fallback.
The fallback would be the upwards mentioned.
Yeah, I know you told me this last time and you just said it, but why would it be none again?
Let's just go with the discard case again. So we have something like let this within a closure. So, so that means when we do the new analysis part of this, we will never see the use of this.
Yes.
And that would mean that the expression ID would be none because, because when we did the old analysis has the initialization step where we'll go and create places for everything. And
yes. So is this only for those cases where we used to capture it and now?
Yeah, it will end up being that. I had also done this because of some of the work that was done around improving diagnostics for, but I think we have a better workaround. Yeah. So if there's something like, I think
it might be good to add a comment about that in the
yeah, It won't be about the why this is an option. Yeah, I need to
Yeah, just
document.
saying like, here is a scenario where it can be none.
Okay, I'll do that.
Otherwise, it's
Okay, I'll do that. Then we have the captured kind, which is basically the upper capture as things are today. This is just like maybe rename it, but that's not important.
yeah.
Okay, so this is what the final structure sort of looks like for this one. Is the final structure that will be for that will be within our closure. So this is for a given closure. Give me the root variable min list. If someone has better names, please. I'm bad at naming things, so suggest them. This one is given a root variable. Give me the min capture list for that root variable. So again, this is missing some comments that
I see.
I should have. I wrote comments and then I deleted them when I was when we
No
were
worries.
working through things.
I have a total nit that helps me, which would be that if you reordered these, I would find it easier to read them.
Okay.
But,
Yeah.
I like to start from the top down, but it doesn't really matter. I see now how it's set up. So the min capture information map, that's the main thing. What is this def ID?
Def ID is the closure def ID. So it's just like it's similar to closure capture. So for a given closure, give me the min captures.
Got it. And then does that mean we're going to have a global map for all closures or just closures in a function?
Sorry. This is it's similar to how closure captures is done.
This would be per item, I guess, right? Like for a given function, there can be more than one closure, so you have a map from the closure ID or something like that.
Yeah. So it's similar to like this is within the type check table. So
yeah.
How we do closure? Yeah.
A root variable, a minimum capture list.
So I'll give an example. It might be easier to visualize. And
this data structure makes sense. Yeah, but example is really great. By the way, for these kind of things, my favorite sort of docs is here's some Rust code and here's the data structures that come out from that code. Super
I think I have a video. I shared it on Zulip where I did all of that, but I should have, I guess, left I explained it right above this, but then I ended up deleting them. Yeah. Feel free to I guess post that on the we have the 229 playlist. So it kind of explains capture analysis and how it has changed.
Yeah.
And so but basically the way it will store things would be foo and basically paths from foo that will end up getting captured. And whatever. So it's basically this is what we're trying to store, and so that's essentially what the structure will end up looking like once capture analysis is done. And
okay, I see. Mm-hmm.
And the way arrays are going to get handled is
I'm curious why I mean, is the reason to index by the root variable partly so that we can collapse this very easily, like for when we want backwards compatibility mode, or
I guess this one could be one of the this could be a hash map, or
no, I mean,
actually no.
I don't care if it's a index map or a hash map. What I'm referring to is there a time when you want to look things up by the root variable?
Maybe. At least with the old analysis, it makes things easier because everything was root variable based. So
right, so you can just kind of take the keys and then you have the old result.
That and not also just even if we actually knew. Oh yeah.
I think that you are going to want to look it up, but go on.
Yeah, but I don't remember the case, but I think there are a couple places we might just want to look at the root variable to make quick decisions.
I think in mirror, I think you're going to want it in mirror construction when you get there, because what's going to happen is you'll have an expression like foo.z.bar. whatever, and you are going to start from that outer expression, and the first thing you're going to do is recurse all the way down to the base, which is going to be foo.
Yeah.
And then you're going to want to look up and say, are there any things that start with this base that we captured? Because this will then be an upvar reference, but you have to take that set and then narrow it down as you walk back up the tree. You see what I mean?
We already, wait, are you saying something like if I have foo.x and foo.x.bar, then reduce it to foo.x?
No.
Okay, then.
I'm assuming you've already done that.
Yes, we have done that. Yeah, we have done that.
I'm talking about when you want to modify
Mhm.
mirror construction, which I think we're not at that point yet, but
Mhm.
we will get there. And you're going to have an expression like foo. You're going to have some path that's rooted in an upvar. Like let's say you have foo.x,
Mhm.
and you want to replace that whole expression with a reference to the upvar.
Okay.
Does that make sense so far? What I'm saying?
Actually, no. Why would I want to replace foo.x with a reference to foo and not the like?
No.
Why not keep foo.x?
Sorry, that's not what I meant. What I meant is there's a field in the closure that represents a captured place,
Yes.
and you want to identify, like you have some expression in the code that's like foo.x, and it needs to be changed to a reference to that field.
Mm-hmm. Yes.
And what I think the way this will work, if you look at that, the way that mirror.
If you know the file, I can open it up. If there's something that...
I'm trying to decide if this is like worth talking about now. I mean, maybe it's just like, maybe we should focus on what you actually did so far and we'll come back to this. But suffice to say, I think that while you're constructing mirror, you will need to look things up by the here ID, or that will be useful. And so the fact that you have this map is a good idea. And we can come back to it later.
Okay. Yeah. Other than that is just implementation. If you want me to go into that, I can go into that.
Well, okay, hold on. So you showed me the data structures, and I'm curious, what have you implemented so far, just to...
So for implementation perspective, we have the minimum capture analysis working to an extent. We still need to debug more things, but...
Okay, so we outlined the data structures to store minimum captures, and you have, you implemented the analysis to compute it. How are you testing it?
So testing right now has been making sure that the data set that we have, like what the current test suite is works, and kind of what we have done is like kind of go through a couple examples and make sure they're fine. What's in the works is have a very simpler test suite that goes through each and every case. So I can kind of show you that as well. That we plan on just putting it in. And
I have one more. Before you go there, I have two questions. First of all, I assumed, but I didn't say, you also have this bridge code that you were talking about before, right?
Yes.
That takes the minimum captures and creates the old style structure.
Yes, we have that.
And does that bridge code for this let underscore equals x case
handle that?
Code preserves the current behavior right now?
Yes. Yes, it does. Actually, if you use old analysis, then yes. If you don't, then no.
And you use old analysis when the feature gate is not present, and otherwise
yeah.
you... Okay.
Yeah, so that's what I was another thing I want to talk about was, do we want to come up with the name? Because right now we just use an environment variable to decide.
Oh, yeah, we should make a feature gate.
Yeah, do you have a suggestion?
I don't know, closure path capture.
Okay, that works. We probably want... Do we want to document this or need any formal process on the name? Or
we don't really need process, but we should document it. Let me see if there was a name. Usually the RFCs are supposed to include a name.
Okay.
But I don't know if we actually did. Oh, it looks like closure capture disjoint. Closure capture disjoint fields was the name of the RFC.
Yes.
And there is, which is a pretty mouthful, but who cares? The problem is path is not actually a word we use, I guess. Yeah, it looks like capture disjoint fields was the feature name in the RFC.
Okay, and we just go create a -z flag, right, for this right now, or
no.
Or feature.
I was suggesting you add a feature gate.
Okay.
I can send you some links on how to do that, but it's
Yeah.
kind of copy and pasting some stuff.
Yeah, it would be nice to have that.
And then you can write tests that have the feature. And what you would do is you can test if the feature gate is enabled in the current crate. And so that would replace your environment variable. It would be like, if the feature gate is enabled, use the new analysis, else.
Yeah. One other thing I was thinking around testing was if we could just, if the feature gate is, I don't want to go with like if the feature gate is set and verbose, but essentially output what's being captured right now so that we can see as we, or like, keep a track of our like the structure that's there for now, and as we keep fixing things and like as we improve, make sure those things resolve correctly and don't change.
That's a very good idea. And have you seen the like Rusty underscore attribute stuff that we use?
Uh, I know there's the Rusty log that allows to print
Not,
certain
yeah, not
that.
that.
Okay.
Something else. So what you can do, I'll have to find a good example.
Mm-hmm.
Hold on, I'm taking some notes in this issue. I just in a comment that I'm drafting, but let's see. I want to put in the feature gate name. To select new algorithm should add feature gate and use that to decide instead of environment variable. So that's kind of an action item. So, right. So in terms of testing, let's find a good example. What you can do, what we do a lot, which I'm quite fond of, is we add special attributes into the language that are not like publicly usable. And they always have the name Rusty underscore something. And I want to find a good example for you so that I can show you. But what happens is then you have special code in the compiler that when it sees one of these attributes, it dumps extra information usually as errors. Like it'll just make a fake error with whatever info you want. And then you can just use the UI testing infrastructure.
Yeah. Okay. That's kind of what I was going for.
So let me find a good example just to give you a template to copy. Why can't I find any? I remember there's some for variance. Oh yeah, so if you search for Rusty underscore variance, you'll find some tests. You can search for it right now, yeah. Look under not in the compiler, back in the under the tests.
Yeah. What's
Rusty? Lowercase. Actually, I can just tell you the test file to open. It's just open up source test UI, and then variance, and then
like, variance or variance? CE or CE variance
slash, and then kind of any file in there. Variance associated types.rs, for example.
Okay. Wait, I might have just opened the one that does not have it. Yeah, okay, this one actually does not have it.
Okay, yeah, bad choice. Try this
one. This thing?
Nope. That what you see, open up all these hidden things.
That's a feature gate.
Yeah, you do need the feature gate, but let's ignore that for a second. Go down one line. So this attribute here, this is telling the compiler, hey, you see that error that occurs on the next line with the minus and the plus? So that's a special error that is just dumping internal debug state that's not otherwise accessible. And
I see.
It's generated because of the presence of this attribute.
I see.
And so what that's doing is we computed the variance. I don't know if you know what it is. If you don't, it doesn't matter. For each type parameter. And so that debug state is telling you the first one is minus and the second one is plus. So you can add something like that for every closure, you dump out the minimum paths that were captured, and then you just have to add error annotations that will like log what you expect to see, and then you're all set. You can search it. You'll find in the compiler. So what the feature gate does is these special attributes are under a special feature gate called Rusty attributes.
Okay.
That's why it's there. They will never be stable because these aren't a real part of the language. They're an implementation artifact.
Okay, that makes sense. Okay, so I'm just gonna put notes in this chat about Rusty.
Yeah, you can go ahead. I'm also putting notes, like the things to search for at least.
Okay, yeah.
You might add like a Rusty minimum captures attribute that dumps minimum captures for each closure.
I'll just call it capture new analysis or precise analysis or something.
Yeah, you can call it whatever you want. As long as it starts with Rusty underscore, it's fine.
Yeah.
Okay, so this is really good. So the minimum analysis is kind of working.
It's kind of working. We still need to do a little bit more around handling arrays properly because like just making sure that the root is the moment we see an array, we just stop doing anything after that.
Yeah. Do you have, I mean, once you add this attribute, it would be great to create like a directory in the UI, you know, and just go through the cases and unit test it basically.
Let's see. I have let's just do. So this is one of the basic examples from we had. Okay, so these are not just min capture. These are also just to make sure the neo-analysis in general, like precise capture is working fine.
Mm-hmm.
So a lot of the examples here are for precise capture. So this is an example that I took exactly from the RFC where this does not work out because one is mutable, one is immutable. And so there's that test. This test is the simple min capture test where this is being p dot x is used in a particular way and p itself is used in a different way.
Yep. So,
sorry, I can open that. I actually
no, this all makes sense.
Yeah. This is to make sure tuples are working fine. I don't know if you want me to go through all of them, but yeah, we have a bunch of tests.
I probably would like to look through them, but I have another call in 10 minutes, so maybe I trust you that you have a good set of tests.
Yeah, these are fairly small but concise in the sense what we want to test. So
yeah, that's exactly what I had in mind. So you would just add an attribute to each of those tests and dump the errors.
Yeah. So that's
the other thing. I'll just say one more thing is you could, instead of making it report errors, it might be better to make it report warnings. Though I have to double check whether like run past tests or whatever, if they still check for warnings. I can't remember. But I was thinking that some of those tests, the ones that are meant to compile correctly, it might be useful for them to, be able to actually run the whole way through compilation and make sure it
I have another suggestion, might not be the best one, but basically have two variants. One that just makes sure it passes and the other one is it outputs the logs.
That's the other alternative, yeah. And you can, then you just have twice as many tests sometimes.
Yeah, which could be annoying, but that would be the other.
It might be annoying, but it might also be good because then the test is smaller. Like one test is really targeted at just the one thing, and the other has got sample data.
Yeah, so this is about it, I think, what I have to share right now.
I'll just post this comment then. I posted it in number 7. Maybe that's the wrong place.
Wait, number 7 should not be an issue that we are working on right now, or I might be remembering wrong things. Give me 1 second. Let me pull it up.
This is use here, place in closure capture.
Okay. That's the first one. That's the first part of this where we do the basic changes. Yeah.
That's fine.
That makes sense.
This is great. I mean, it seems like you're making great progress. I think jumping back to the project board, you basically got because all the in progress things are really close to done.
Yes.
And so probably before the next week, we won't get, we're not going to pick up any new items, right?
No. Hopefully by the end of next week or about 2 weeks from now, I want at least everything that's open right now and number 6 to close, because number 6 is basically removing the bridge.
Yeah. I was going to ask about number 6. What's the status?
Number 6 is partly done because it's required in some of these places. Okay, another thing that comes out of closure captures and the bridges, that the order in which things are in upwards mentioned is not same as order in things in closure captures anymore. So
is that relevant?
It's relevant for parts of the code because after type check, if something is using upwards mention and some other places are using closure captures, the ordering of fields will change because of types.
It's definitely relevant for that, yes.
Yeah, so from that perspective, we saw some errors. So parts of this will already be done by the time we are done with I think number 4, but more of them will change. By the time we remove the bridge, all of that will be done. So hopefully if in 2 weeks or so, we can probably finish most of this.
Okay.
That's there. And then again, this is hopefully because most of us are kind of on co-op or have like busy school schedules, but yeah, that would be an ideal scenario. And then I think by end of October and like early November, more would probably be the only thing that's left.
Okay. So that sounds really good. We have 5 minutes left. I could go back and explain the thing I was trying to explain, but it's really about, in terms of the project board, I was really talking about number 10, I think, and how
Yes.
this will actually be implemented.
Mm-hmm.
So maybe let me
I
share.
can. Let me stop.
So, I don't know. I'll just use this as a place to type for now.
Mm-hmm. I think that's a good place to keep track of things. Yeah.
What I was going to say was that in here lowering, right? Imagine we have something like this. Okay. So when we actually, when we're generating the mirror, we're going to have a here like, I don't know, I forget what the names of the heres are, but it's a standard AST thing, right? And what I was suggesting is that you don't actually, like, we want to replace this entire, let's put a little function call. We want to replace this entire subtree with a reference to the field that represents foo.bar.baz, right?
Yes.
And the annoying thing is that the way it works today, let's just start with that, is we compile Baz, it says first compile bar, it says first compile foo, and now because foo is an up var, we return a reference, like we return a place like self.0 or something.
Okay,
right?
yeah.
And then this becomes self.0.bar, and this becomes self.0.baz or bar.baz. And that's kind of easy. It's a little bit harder when it's not always the leaf that you want to replace with self.0, but some subtree that you have to recognize. Yeah. Not super hard, right? There are a bunch of ways you could do this, but the way I think would probably be easiest is when you get to the leaf, so when we get to foo, we look it up in that map that you have indexed by here ID, and we'll see that it is present and that there's a set of captured places, right? And we know that it must be part of some subtree that is in that set, because otherwise, like, we missed something.
Oh, okay. I see what you're. Okay.
So instead of,
just to
get where I'm going now.
I think I know. So just to make sure, we first do a check just based on the root variable, and then we know that some path within, like if, let's say, the only thing out of this we were capturing was foo.bar, like that was like the precise how we are stored things. So we know we have a reference to foo.bar somewhere, and we can just quickly go from there. Okay.
Yeah. So basically, you'll start out with the set, and then you'll return it to your parent, and the parent will say, "Oh, I am loading bar. I see that like bar, that can further narrow the set. Once it gets down to a single item, then you can make a reference to that field. Until it gets to a single item, it should never get to 0 items because that would be bad. But it can be still ambiguous which field you need until you've gone far enough up the tree to identify it. Does that make sense?
Sort of. So basically, we want to make sure that some parent path is in the captured list that we had generated, right?
Yes.
I think I'm still a little confused. Might need me to look at code and get a better idea what's happening, but I think it sort of makes sense.
So okay. I'll just say one last thing, which is today mirror construction says like, it's like here node to mirror place, essentially. And what I'm proposing is it would return here node to either a mirror place or a like set of upvar captures. And the reason is you may not know yet. You need to know information from the parent. Like the leaf node doesn't have enough information to actually construct a mirror place. And so you could do one of two things. Either the parent can pass down the information it needs, but we don't already have a data structure that can represent that, or you can pass it back up. I don't really have a strong opinion about this. This is just sort of how I imagine it could work. And then the field bar node would get back a set of captures that is like not a singleton set. That's not quite right. It has a little more work, but the idea is that you would narrow it down and eventually and return it up, and the field baz node would return the mirror place self.0. So why am I saying multiple? I'm talking about multiple because you might have foo.bar.baz2, right? So you don't know, when you just look at these foo nodes, you don't yet know which one of those you want. You only know when you get to baz or baz2.
Oh, okay.
But yeah, that's the idea. So we'll figure it out when we get there. However, the point is, I think you're going to want to look things up by the root.
Okay. Yeah, no, that's good. Yeah.
All right, I do have to run now.
Okay, thank you.
See you later.
See ya.